Okay, this is the document 24 rigorous limit proofs. It's based on a document and a YouTube series by Black Pen, Red Pen. And I'm just going over what he does for our students at Essex County College or any other students that want to use it. So I kind of, write down some definitions for you. I'm going to look through those. There's links over here. If you want to look at those links, you can, right? They link to the Black Pen, Red Pen's treatment of this, which is a good treatment. I think it's really quite a good treatment, by the way. What I want to do, though, is do the problems over here. Now, certainly, as I go through the problems, I want to point in the blue area, there is a solution to the problem written up for you, including the definition I'm using to do that proof. And certainly work done over here. The video on the side is what you're watching now, by the way. I want to say there's also these problems are without solutions as well. So if you click on the without solution, I'm going to do that now. And it brings us to the complete problem set, right, without solutions, by the way. There's 24 problems there. Some are difficult, some are pretty easy. The bottom line is the more practice you do, the better you get at this. So let's go back to the with solutions. And I want to do problem number 1. And I'm going to go to the whiteboard to do it. I realize the work is written over here for you, but I want to go through how we're writing this up on an exam, what it would look like. This would look like if it was typed up, by the way. So let me see if I got up I got to get my whiteboard out, and let me see where that is. Right over here, and let me do a new whiteboard. And let me expand that out. Let me get rid of the keyboard. And what they want me to do is they want to prove. All right. What do they want to prove? They want me to prove the limit. Let me just get my pen out. Yeah, we're doing okay. They want to make sure that I can prove this. And the limit. Again, this is problem number 1. As x goes to 4, of 2x minus 3 equals 5. Now, the limit's finite, and it's 5, and x is approaching a finite number. So this is the traditional epsilon delta proof that we're going to present to you. All right, so the first thing I do is, there's something given to me. I want to say what's given to me. This is the epsilon part. What's given? That I have some epsilon that's greater than 0, all right? The next thing is the tough thing. It's the choose part. What do we need to do? We need to choose a delta. And by the way, the delta's got to be greater than 0, but I'm going to say that I'm not even sure what this is yet, right? So I'm going to say this comes from really the last step, right? But I need to choose a delta at some point, by the way. I'm not ready for that. Now, what I'm going to do now is suppose. And what I'm going to suppose is that the difference between 4 and x is less than delta. All right, let me write this down for you. That the distance between x and 4 is less than delta. I also want to go on to say that we do not want to touch the 4, so the x cannot be equal to 4. If the x can't be equal to 4, the absolute value of x minus 4 cannot be equal to 0. So what does that mean? This is greater than 0, all right? Here's the check part, and the check part is what's going to allow me to get to the delta, at least hopefully. So what do? It's going to be the absolute value of the function, which is 2x minus 3, minus the limit, which is 5. All right, now I got to look at this, and my hope is I'm seeing the supposed part here. I just don't see that yet. So I'm going to manipulate this a tiny little bit, and I'm going to say this is 2x minus 8. And this way you spend so much time in pre-calculus dealing with absolute values. I'm going to factor the 2 out, and what do you get? 2x minus 4. Now what do I notice right now? I notice that this is going to be less than 2 delta. How do I know that? I'm looking at the supposed part, and I see that x minus 4 is less than delta. So 2 times x, the absolute value of x minus 4, is going to be less than 2 times delta. Now, by the way, this is supposed to lead to an epsilon. And I'm looking at this over here. My question is, does it lead to an epsilon? And it does. So what I got to do is I got to now choose the delta now. But I want this to be equal to epsilon. So I hope it's obvious that what I have to choose for delta. The delta would have to be equal to, well, to make it 2 times the delta equal to epsilon, I'd have to make the delta equal to epsilon over 2. All right, let me write this over here, and the proof is now complete. This is epsilon over 2. But I want to emphasize again that this is greater than 0. And now we're done. All right, we're done. What some people do after they're done is write down QED, which we showed what we want to show. Now, red pen, black pen, what he's doing is putting a box down, and he's saying that's how he's completed his proof out. And by the way, you see it in textbooks a lot. You see two things. When they're done with the proof, they say QED, or they put a little black box down that's shaded. All right, that's number 1. Thank you.